Hi there, grade 12s, and welcome to today's lesson on the counting principle. This is a new section that's included in your syllabus this year. It's come from the old paper 3 syllabus, and I really hope that you guys are going to enjoy it. I think it's a very interesting section and one which I really think you guys can get your teeth into and understand really nicely. So let's get started and let's start talking about what it is that this counting principle is all about. All right, the first couple of things, what we're going to be doing this lesson is looking at the definitions, just explaining to you what the fundamental counting principle is all about. And we're going to be having a look at just different rules that we can apply, counting rules that we're going to apply to help situations look a little bit more easy to understand, okay? So those are the rules that we're going to be having a look at, and they basically involve your fundamental counting principle. It involves your factorial notation. If you don't know what that is yet, you're going to understand it by the end of this lesson. And when we put arrangements of items in a row and we count all of those different possible arrangements of items, how do we do that? Okay, and you'll be amazed to see that it actually is very doable. Okay. All right, guys, so let's quickly talk about what it is that you need to make sure that you can do in this section. When you are working with this section, please make sure that you are able to recall and apply the rules of counting. Okay, so now what are these rules of counting? Let's have a look over here and let's just quickly discuss each of the rules of counting that you need to know to understand this section. Rule 1 basically says this. And girls, I'm sure you're going to like this example because it's going to apply to you nicely. Let's say when you open your wardrobe in the morning and you're trying to decide what outfit to wear, and you're getting bored of all the clothes that you have in your cupboard, think about this. Let's say we have got 3 shirts, we've got 4 skirts, and let's say we've got 5 pairs of shoes. Okay, and with that we need to make a combination of an outfit. Okay, now if we look at the fundamental counting principle, what it is that we need to do is this. We need to take those 3 shirts, we need to multiply it by the number of skirts that we've got, and we multiply that by the number of pairs of shoes. Okay, so 3 times 4 is 12, 12 times 5 is 60. So what you'll find is that in fact there are 60 different combinations of outfits that are sitting in that wardrobe with just those items in it. Okay, so in general, what is the rule there? We take however many items are in the first group, multiplied by however many items are in your second group, and that will give you the total number of combinations of that particular situation. Okay, so that's the first rule to be aware of. Then let's see what we can do with rule 2. Okay, rule 2 refers to your factorial notation. Okay, right, this situation over here speaks of it something like this. Let's say we have got 6 children, all right, and we need to arrange those 6 children on 6 chairs that are sitting in front of us. Okay, we can arrange them in any way we like, but all 6 children have to be seated on the 6 chairs. Okay, now let's take these chairs. So we've got 1 chair, 2, 3, 4, 5, 6 chairs over here, and there are 6 children. In the first chair, we can put any of those 6 children. It doesn't matter how many, it doesn't matter who we put in there. But once we've seated the first child, there's obviously 5 children left in which to seat. So the second seat has then got 5 children that we can choose from to put in that seat. Once those 2 are seated, we're now left with 4 children that we need to seat. So that's going to be 4 children over there. And so on. The following, we'd be left with 3 children, with 2 children, and the last child is going to get the last seat over there. And to calculate the different, how many combinations we can get, we multiply those together. Okay, now that's a bit tedious. We don't want to keep writing 6 times 5 times 4 times 3 times 2 and so on. So we have what we call the factorial notation, which is there to make it a bit easier for us, and this is what it looks like. Instead of writing 6 times 5 times 4 times 3 and so on, we write it as 6 factorial. Okay, and 6 factorial will work out for us. So in fact, let's grab our calculator out. The way we would do it is we'd have our 6 and our factorial button is that one over there. And that tells us we've got 720 different combinations of pupils and how we can seat them in that situation over there. Okay, so guys, factorial notation, where you have a set amount of values and you need to arrange those values in the same number of ways, and that's your factorial notation. Okay. Rule 3 is still working with factorial notation, but it involves a situation that's slightly different. Okay, so this is rule 3. Let's say we've got this. We've got 10 children in a race, okay? Now, only 3 people can come first, second, or third, all right? So we need to determine the order. Let's just make sure we've got this right. In fact, let me read my example over here. We've got 12 different singers, and they're going to occupy the first 3 places in the South African Idols, okay? So we want to know how many different ways can these first 3 places be occupied. Okay, now there's 10 people, and there aren't 10 spaces, and there's only there's only a first, a second, and a third, all right? So the way we have to do it is like this. We take our 10 people, and we're going to say 10 factorial because we're going to take the total number of combinations of all the people. But we need to divide it by, and what we do is we say 10 minus the 3 places that the 3 positions that we've got, and we calculate the factorial of that over there. Let's just add that up nicely. Okay, so how many possible places have we got here? We've got 10 factorial divided by 10 minus 3 factorial. And we get, again, okay, so that happens to be the same number, 720 possible different combinations of a first, a second, and a third winner in your idols, okay? So how do we make a general rule out of that? If I take my total number of values, so in this case it was 10 contestants in the singing competition, and we divide that by the total number minus the number of places that we've got. Okay, here we only had a first, second, and a third, so there were only 3 places. So we subtract that, let's call that R, just as a general value, and we work out the factorial of that, okay? And that will then give us the total combination of, in that case, just the 3 places. All right. All right, and fourth, we've got the list rule over here. Rule 4. Okay, if we have a situation where anything is being repeated, okay, so we're going to use an example very quickly of a word, okay, and in a word there might be letters that get repeated. So for example, we're going to take the word needed, okay, and we need to determine how many different ways we are able to rearrange the word or the letters of the word needed, okay? But it depends on whether we're allowed to repeat letters or whether we are going to consider the letter E or D, which are the repeated letters, we're going to consider them as all identical, okay? So what do we do when we've got these repeated values? In that case, we're going to use this over here. We're going to take the total number of letters and the factorial, and we're going to divide that by this is called M1 just in general terms, and M1 is where the number of letters that are identical. So in this case, I had 3 letters of E which are identical, and we take the factorial of that. We multiply it by the next lot of repeated values, which in this case would be D, and there's only 2 of those, and that would then help us calculate the number of different combinations of this word needed if we were considering the letter E and D identical. So to take this as an example, we had 1, 2, 3, 4, 5, 6 letters in total. So I've got 6 factorial divided by, now the letter E, there's 3 of them, okay? So I've got 3 of the letter E times by 2 of the letter D, all right? And when we put that in our calculator to work that out, we've got our 6 factorial divided by 3 factorial times by 2 factorial. And we get a total of 60 possible combinations there. Okay, so guys, those are the rules that I'm going to be really working quite thoroughly through today, and hopefully by the end of it, you'll be able to identify for yourself which ones of them we're going to have to apply. All right, so let's have a look at some examples. Let's take the first one. We've got the word Florida. Consider the word Florida. You are required to form different 7-letter word arrangements using the letters of the word Florida, okay? So we've got to rearrange them, and how many different possible arrangements can I make with the letters of the word Florida, okay? Well, the first one is this. How many possible arrangements can be made if the letters may be repeated, okay? So if they may be repeated, each one of the letters can be used over and over again, okay? Well, if that's the case, then we have to consider that the letter F could be used a total of 7 times, the letter L could be used a total of 7 times, and so on for all of them, all right? So in this case, because we can consider the letters are being repeated, we have 7 letters, 1, 2, 3, 4, 5, 6, 7 letters, and every one can be used 7 times, so therefore it would be 7 to the power of 7, okay? That would be how many possible combinations we've got over there. So 7 to the power of 7 is giving us 823,453 possible combinations. I bet you didn't think there was that many, hey? Okay, but now what if we can't repeat the values or the letters? Okay, so let's consider it. Let's say we can choose any one of the 7 letters as the first letter in the value. So we've got a choice of 7 different letters that we can put into that first place. Once that letter's been used, though, you can't repeat it, so we have to take it out. So therefore, the next letter in your word would have to have only 6 possible letters to choose from. And the next would have 5 possible letters to choose from, and so on. Okay, so do we remember that we don't need to stand there and write 7 times 6 times 5 times 4? There's a more efficient way of writing that, and that's going to be your 7 factorial. Okay, so let's see if we can see what that is. 7 factorial is going to be 5,040, so obviously much less in terms of how many different combinations, but still quite a lot. Okay. Example 2. A security system requires a user to choose a security code, and the code consists of 4 digits. How many different codes can be chosen if, okay, first example, the system allows repetition of digits, all right? So we've got to consider that we've got digits from 0 to 9. So we've got 10 different digits that we're going to be able to use here. And each of those digits may be repeated, all right? So therefore, each of the 10 digits is going to possibly be repeated 10 times. So therefore, 10 to the, 4 times, there's 4 places in the code. So 10 to the power of 4 would be then the total, which is obviously going to be 10,000, okay? So 10,000 possible combinations of numbers there. But what happens if you can't repeat the numbers, okay? So what we would have to say is, of our 4-digit code, we've got 10 possible numbers to choose from, all right? Once we've chosen one of those digits, we can't use it again. So for the next number in our code, we'd have to have 9 different digits to choose from, followed by 8 different digits, and then followed by 7 different digits. Okay, so therefore, what have we got there? If I multiply it together, can I say 10 factorial? Well, no, because remember, we haven't gone all the way down to 1 here. So the way we're going to write it is we're going to put our 10 factorial over 10 minus, there were 4 possible places in which to fill the digits, and we're going to make that our factorial. So you can work out that on your calculator. 10 factorial over essentially 6 factorial will give you the total number. We should get 5,040 as the solution over there. Okay. Let's take an example where we take textbooks, okay? You've got your textbook sitting on your shelf. You've got an accounting, a science, a Zulu, and a maths textbook. And you are sitting there wondering, how many different combinations can I place those textbooks in? Okay, well, first thing, you can't repeat any of these. I'm sure you agree with that. The maths book can't be magically repeated to become all 4 of the same book. So we can't consider it being repeated. So therefore, we've got 4 places on our bookshelf. I can put any one of the 4 textbooks in the first place. So the first place would have 4 possible books. The second place would then have 3 possible books to choose from, 2 possible books to choose from, and 1 possible book to choose from. So again, your 4 factorial. Okay, right. And let's take one more basic example before we make them a little bit more difficult. We've got how many different ways can the letters of the word marks be arranged? So, and again, it says that repetition is not permitted. So I'm sure we're getting the idea now that we can arrange it, but in this case, if you can't repeat the letters, then once it's been used, we have to eliminate it from the total number of letters that we have. So for the first one, we have 1, 2, 3, 4, 5 possible letters to choose from, and that would be my first letter in my word. Then I would have to choose from 4, from 3, from 2, and from 1. So therefore 5 factorial, and what does that give us? Sorry, my calculator. All right, we've got 5 factorial, and we're getting 120. So we've got 120 different ways of arranging the letters of the word marks to actually give us all different words. Very interesting, isn't it? All right, guys, what I'm going to do is take a very short break. And when we come back, we're going to have a look at ones that involve a little bit more understanding. So don't go anywhere. We'll be back now. Hi guys, hope you all had a nice rest there for a few minutes and ready to get back into a few counting principle questions. At this point, can I just really reinforce that you need to go back over past papers with this question, as with obviously all of your maths, but these ones, it is a new concept to you guys. It's something you haven't really worked with before, so getting familiar with it and practicing it with past papers is really, really essential. So go and find them and practice them, okay? You'll find that the questions will look very much like what I'm doing over here today. All right. Okay, let's have another look at another question. Similar, okay, so everything we've done up until now, you'll start recognizing. The first thing saying, consider the letters of the word night, okay? We're going to notice over here that none of those letters are repeated, so we're not going to worry about what we had to deal with in the previous question when we had the word needed. Here there are no repeated letters to worry about. So question 1 is how many word arrangements can be made with this word and the letters are not repeated, okay? So what do I have to do? Think about it. We've got 1, 2, 3, 4, 5, 6 letters, okay? We can arrange them in any which way, but you can't repeat the letter. So for the first letter, we've got, 1, 2, 3, 4, 5, 6. We've got 6 different letters to choose from. Once we've used one of those letters, there's only 5 left. So we have 5 letters to choose from. Then we have 4 letters, 3 letters, 2 letters, and 1 letter. And remember that that can be written as 6 factorial. And that gave us 720 different combinations of the letters of the word night. Okay? So guys, are you recognizing the questions? You can see the kind of thing. Generally, it starts off asking you pretty simple. Then they go on to start making it a little bit more complicated by making certain letters having to start and end and what have you. So let's have a look at an example like this. How many word arrangements can be made with this word if the word starts with K and ends with T? So now they're limiting us a little bit because we can't just arrange it whichever way we like. Of the 6 letters that we've got in the word night, we have to start with the letter K and we have to end with the letter T, okay? Which leaves us with 4 letters left that we can arrange inside this space over here, all right? None of them are the same. There's no repetition of letters over here. So all we have to do is take what's left inside there, which was 4 factorial, and get the answer, okay? 4 factorial is giving us 24. Different possible ways of rearranging the word night if K had to be at the front and T had to be at the end. Okay, all right. Now let's get a little bit more challenging. Radio, we've got how many ways? We've got boys and girls over here, and we want to know first of all, in how many ways can 3 boys and 2 girls sit in a row? Okay? Are they asking about any kind of order? Do they want us to group the boys and girls together? I think you can agree with me that no. They're just asking how can we arrange these boys and girls together? All right? So 3 boys and 2 girls, we've got 5 people in total. So 5 factorial, which let's work that on our calculators. We've got 5 factorial. Take note of the buttons that I'm pressing here, please. 120 is the total number of combinations of boys and girls where there's no particular order that needs to happen over here. Okay? But what if we do put a bit of an order restriction on it? In how many ways can they sit in a row if a boy and his girlfriend must sit together? Okay, they have to sit together, so we have to look at the combinations that we have. So let's see, we have 3 boys and 2 girls. So let's just write this over here. So we've got 3 boys and we've got, no, other way around, sorry. 3 boys and 2 girls, okay? And these 2 here need to sit together, okay? So this boy and this girl have to sit together. The rest of them can sit wherever they like. So this boy can sit wherever he likes, so can this boy and this girl over here. So therefore, we've got a total number of 1, 2, 3, 4 different positions that we can change around, okay? So therefore, 4 factorial is going to be the number of different positions that we've got in that row. But remember that with inside that block of that boy and that girl, those 2 can swap around as well. So we need to make sure that we then take 2 factorial as well. So we've got 4 factorial multiplied by 2 factorial, and we've got 48 combinations over there. Quite a bit less obviously than what we had previously, so just making those 2 wanting to sit together, you can see how much it reduces the number that we're working with. Okay, that was 120. Okay, now let's see, in how many ways can they sit in a row if the boys and the girls are to sit together? So we want all the boys together and all the girls to sit together. So we want this over here. We want the boys together and we want the girls together. So therefore we're going to block them off. We can't have them in any other way. They've got to be next to each other. So therefore, how many places do we have in that arrangement? There's only 2 of them. There's only 2 blocks over there. So 2 factorial is going to be the arrangement of the boys and the girls. But as we've said before, the boys inside that block can move around, and there's 3 of them. So 3 factorial is then giving you the number of combinations of the boys, and there's 2 girls. So 2 factorial is giving us the combinations of the girls. Okay, so that worked out. What have we got? 2 factorial times 3 factorial times 2 factorial. And we've got 24 combinations. Okay, right, getting smaller and smaller. Okay, now let's see what we've got in the next question. Question 4. In how many ways now can they sit in a row if just the girls are to sit together? All right, so let's look at a scenario here. The girls have to sit together, so those 2 have to be like that. But the boys can be moved around. So we could have a boy in front and 2 boys behind. I could have 2 boys in the front and 1 boy behind. I could have 3 boys in the front. I could have 3 boys at the back. That doesn't matter. But what does matter is that the girls stay together. So we've blocked off the girls, which means that we're now sitting with 1, 2, 3, 4 numbers. Okay? So 4 factorial is that combination. But let's not forget that what is inside here can also swap around. So 2 factorial will then give us the combination of our girls. All right, so 4 factorial times by 2 factorial. Oh, not -1. Factorial. Let's just fix that. There we go. And 48 is our answer over there. Okay, so obviously it increases because now we're not just limiting, we're only limiting the girls, which is not as many as, so it makes it quite a lot less restricted. Okie dokes. Now we want to know, that was question 4, now question 5. In how many ways can they sit in a row if the boys and the girls are to alternate? Okay. Well, they could only alternate, obviously, if there's an odd number, and we'd have to have one more than the other. So in this case, it'll work. We've got our 3 boys, and if they have to alternate, it means that the girls are going to go between them like so. All right? So what do we have over there? There is only one possible combination of that. We can't change that any other way. So there's only one possible combination as such of that. Okay? But within that block, remember, the boys can change position. This boy could go over there, this boy could go over there, this one could go over there. So the boys can swap around, which means that, oh, not that equals, sorry. That's times by 3 factorial. And same thing with the girls. The girls can swap around, and they're obviously 2 factorial. Okay? So that is giving us just 3 factorial times by 2 factorial. Obviously, 1 is not timesing it by 1 is not going to change anything. We've got 12 different options if the boys and girls were to alternate. Okay. Grade 12, I really hope you guys are understanding this. I hope you're finding it easy, and I hope that this is going to be a section that you get full marks for in your exam. Okay. Right, let's have a look at the last question that we've got over here, question 10. Okay. Another word question. The reason I've included a couple of these in here, guys, is simply because if you look in your past papers, you'll see that it's a very common way of questioning this section. Okay, so as I have said before, go and practice them. Okay. Rightio, we've got the word technology. Okay. Lots of letters. We've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters in the word technology. And we do just need to point out that we've got a repetition of the letter O, and that's all. Okay, there's only O as a repetition over there. Okay, how many different arrangements can be made with this word if the repeated letters are treated as different letters? Okay, so in other words, what we're saying is we've got 10 different letters, 10 different possibilities of arrangements. Okay, and as we've said before, if I use the first letter, the first letter in any one of the arrangements has 10 possible options to choose from. Then we would go down to 9 possible options to choose from, then to 8, then to 7, and we go all the way down to 1. And remember that instead of writing this whole long string of numbers like I'm doing over here, we can just say 10 factorial. Okay. And our 10 factorial is giving us 326. So what have we got here? 3628800. So 3,628,800 different possible combinations. That's enormous, hey? Okay. How many word arrangements can be made with this word if the repeated letters are treated as identical? Okay, so remember now, if we've got the letter that's repeated, the first thing we need to determine is how many times is it being repeated. The letter O is being repeated twice. Okay, so the way we do this is we take the total 10 numbers and we divide that by the number of times the repeated letter is being repeated, and O was repeated twice. So therefore it's 2 factorial. Okay, so 10 factorial over 2 factorial, and that's giving us 1,814,400 possible combinations. Still obviously an enormous amount, but quite a lot less than what we had in the previous question. How many arrangements can we now have if the word starts and ends with the same letter? Okay, well, the only option I have with that is that of the 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different letters, the only letter that is being repeated is O. So I would have to start with an O at the front and I'd have to end with an O at the back. Those are fixed, okay? We're not allowed to move those. So therefore, the only values that we're allowed to move is what's in the middle over here, okay? Now within that, we've got 8 different values that we can change around. There's no restriction on that. So therefore, we are simply going to have 8 factorial as the combination of letters within those two O's. So 8 factorial, and that gives us 40,320. Okay, all right. Then we've got how many word combinations or arrangements can be made if this word just starts with the letter O. Okay, well, in this case, we are basically allowing ourselves, I'm just going to do it down here, 10 letters, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first letter has to be an O, okay? Fixing that there, we can't move that around, but the rest of them, there's no restriction. We can put the rest of them where we like, okay? So there are obviously 9 places that we can move around. So 9 factorial is going to be our possible combinations there. So therefore 362,880 is our solution to that. Okay. And lastly, how many word arrangements can be made with this word if the word ends with the letter N? Okay, well, instead of starting with the letter O, we are ending with the letter N. There's only one of them there, okay? So it's going to be a very similar situation where you've got your 10 places, so 3, 4, 5, 6, 7, 8, 9, 10, but N is the one at the end. That's the one we stuck with, okay? So it can't change, but the rest of the values are allowed to move around as they please, okay? There's 9 of them there, so that also is going to give us a 9 factorial, so also 362,880 different possible combinations to that. All right. Okay, guys, I sincerely hope that you understand all of that and that it's kind of just, if nothing else, it's given you a good introduction to it, so that you will hope a good revision as well. And that at this point you need to now make sure that you really practice it, okay? It's something that you do need to just become familiar with, and once familiar, it's actually a lot of fun, okay? It's a lot of fun to work out all these different things. Go work out how many possible combinations there would be to win the lottery, okay? Go see if you can figure that out for us. Work out for us how many different combinations of outfits you might have in that wardrobe of yours. It's endless. You can work out many different things. So it is a really interesting section. So guys, I hope that has been a worthwhile lesson spent with us, and I look forward to seeing you again next time. And until then, study hard and goodbye.